Good morning, and thank you, Shervin. As also, thank you, RSA, for letting me come up here and speak for a little bit and take some of your time. So we're going to talk today about first-order security principles and what that means with regard to newer architectural trends. And as I was preparing for this today, I looked at my water bottle here, and it said, "The art of the possible." And I thought, isn't that what part of the allure of being a security architect? We're one of the few people left in security, in cybersecurity, that actually gets to be part artist, in addition to being a technical person and a great listener, hopefully, and a lot of other things, because we have to pull it all together to make our architectures if we want them to be good and sound. This is just the standard RSA disclaimer. So we'll just go through that. What are we going to talk about today? I have a tendency to go a little off script, so I will warn you. I was trying to reconcile what I had with what RSA wants to see, and so we have something that's in between, and the opportunity to go off script is certainly present, and we're going to take advantage of it. So we're going to talk. I'm going to introduce myself. I'm going to talk about the problems that we have to face. What are the first order principles, and why do we really care about them still? I'm going to beat up on the Macomber model for a little bit, because that is the foundation of our first order principles. And I'll talk a little bit about software security, or maybe the lack thereof, or maybe the lack of actually enforcement of software security. And then we're going to talk a little bit about hardware security, and we're going to slide on down to the NIST framework. And then we're going to talk about some of the, how we're going to apply some of these first order principles. And we're going to talk about some of the more current architectural trends, recognizing that there are an awful lot of trends that we're not going to be able to address today, so I had to go kind of with the top four. And final notes, and then conclusions, Q&A, et cetera. So who am I? Why am I doing this talk? I keep asking myself why I'm up here, too. So I'm Dr. Shar Sample. I've been doing this for, I've been doing cybersecurity since the early 90s. Before that, I was a programmer. Yes, I actually wrote bad software. Probably my biggest claim to fame was writing a bug that brought down the European theater for NATO. Yeah. Yes, that was a buffer overflow. So, but seriously, it's given me a good perspective on a lot of different aspects of cybersecurity. And more recently, I've been a researcher. I've been a researcher mostly since 2010. I was a applied researcher when I worked at CERT and BBN, and then after that I became more of a theoretical type researcher. So it doesn't excuse me, though, from keeping up with what's going on in cybersecurity and what are our trends. And of course, architects need to always be, even if they're not going to be able to incorporate the latest thoughts in research, they need to be aware of them, because they have to know what's coming down the pipe, and they have to know how they're going to adjust accordingly. So what are the initial security constructs are old. I mean, we've been using the Macomber model since, what, 1991 or something like that? We say confidentiality, integrity, and availability. It was designed for simple networks. This is back in the day when we said things like garbage in, garbage out. How many people still hear, especially when we talk about AI, say, oh, when you bring up a problem with the data, they say, oh yeah, garbage in, garbage out, we don't do anything about that. I'm willing to bet that quite a few of you hear that from the vendors. To me, that is an unacceptable answer. In the age where we have deep fakes, where data input can be modified and not without detection, that is simply unacceptable. But when we started off, we kind of knew who our users were. It was a kind of, the internet in the old days was a relatively closed community. And then suddenly in the mid-90s, everybody came online, and we started looking at hacking and stuff like that. But lots of things changed, but not these basic security models. So we said, if I can authenticate a person, I can trust them. Except that we don't even really know who the person is that we're authenticating. We also designed these for simple applications. We had a cloud back then. It was called the ISP, but it wasn't being used. People weren't outsourcing all of their data and their infrastructure to the ISP. We had, when we look at the outcomes and the goals, they were able to say, yes, we want to say that you have your data is secure, your machines are secure, all of these things are secure. But we were kind of short on details when they talk about it. So it kind of gave rise to lots of different creative implementations. So First order principle, again, Macomber, that's what everything starts with. And I actually inadvertently put my foot in my mouth one time when I was talking to one of the creators of the Macomber model and pointed out its flaw, look at this. I said, you have confidentiality, integrity, availability. You look at your data in transit. You look at it stored. You look at it for processing. But you never really check it on input, do you? And yeah, that got me. The person got a little defensive. It's somebody I knew from school. So, anyways, what I wanted to go on to say is we have this model. We tell everybody this is our Bible that we live by. We design our architectures around it to accommodate it, yet it's incomplete. Authenticity and non-repudiation of user data, when you live in a world where users are halfway around the world and they're just a virtual entity, how do you really know? There is such a thing as software security. God love him, Gary McGraw has laid out what software security looks like, and for whatever reason, a lot of people just simply don't listen. Gary's work is foundational to how we make cybersecurity good. We've had problems with buffer overruns for decades now. We still have them. We still have problems with unhandled exceptions, race conditions, things like that. All the things that Gary tells us to go ahead and look for. And lo and behold, and he's been on this, I've known Gary for close to 25 years, and he's been on it well before I have known him. Yet we don't do it. How do we make this actually happen? Hardware security. Being married to a reliability engineer, actually he's a mathematician, but he became a reliability engineer and then a quality engineer. He taught me the difference between quality and reliability. Quality is about the process. So I can, if you'll pardon my being so rude and crude, I can shine a turd. And that if I have a good process around it, I have a perfectly shined turd that I can turn over. Now, if I have reliability, that's about the product. That's telling me how close is my product adhering to what the specifications were. And when I do that, I have to consider time and environment. These are, again, things that when you think about what we do architecturally, how many times do we build something and then watch it morph into something else because somebody needed to have, we needed these new features. Well, the architecture will kind of handle that. Well, of course it will handle it, but there eventually becomes a breaking point. We have no way of measuring what that breaking point is. So we have things like performance metrics. And of course, the more recent buzzword, which is actually a good one, is resilience. I like to think of resilience in terms of the 4 Rs defined by Cravallo and Bishop, which is robustness, redundancy, rapidity, and resourcefulness. And it can be in any order. Usually rapidity goes last. So what we're talking about when we're doing that is we're saying, how do I make my architecture so that it's robust? We already know how to make robust architectures. We've been doing that for a really long time. But how do I make it redundant? Well, okay, I have to balance cost when I'm dealing with redundancies. So I have to have software redundancy as well as hardware redundancy, and I have to know how to engineer that accordingly. I can overlap that with my resourcefulness, because if I can prioritize what absolutely needs to happen, then I can say, I can run myself in a degraded mode, so to speak, and then come back to full strength over time. And of course, rapidity is our recovering aspect. NIST, in their infinite wisdom, has a framework for us that they want everybody to follow. And if you noticed, I abbreviated each of these, the identify, protect, detect, respond, recover, for the framework. And I took the first letters of all of them, except I had 2 R's. So if you notice, it's really heavy on identification. Just about every one of these different strategies, NSA's top 10 cybersecurity mitigation strategies, actually come back down to, well, I'm going to try to protect and I'm going to identify. Okay, we have these other things we have to consider here. I can protect I can be robust and protect myself and things like that. But what am I protecting myself from? Am I protecting from users? Am I protecting from machines that go awry? What happens when I start bringing in newer things like artificial intelligence, machine learning, right? Because now I have other things that I have to consider that kind of take on a life of their own. I mentioned the 4 R's of resilience, and you can see that it does align very easily. Actually teach a course out of Boise State on it, and we have a lot of fun with students coming up with resilient solutions to the problems. And we can take, actually one of the exercises I have them do is I have them look at any service that is offered on the internet. Like most of them choose DNS or HTTP, but it's kind of fun watching them go through the exercise where they have to identify where it's robust, where it has redundant features, where it has resourcefulness built in, and of course rapidity. And then we find the gaps and we say, okay, in a perfect world, how would you fix this gap? We can't necessarily fix it in the class, but we can at least start the process by identifying where these gaps exist. And as architects, we ask that you do the same thing too. Nobody's going to make a perfect architecture. I'd like to think I did back in the day, but at least it was good enough. So we can acknowledge where our gaps are, and then we can keep ourselves busy by figuring out ways to start closing those gaps. And sometimes it is just process. Other times there are products that come into play. So this is the old, I don't know how many networks I put together that looked kind of like this, the old simple network architecture. You get your little DMZ, you get your firewalls, you got, your little area for where you're going to put your sandbox area, you got your public servers, all this other fun stuff. That architecture worked well back in the day when we had these old models. When we looked at how we're going to go ahead and do did I just do the wrong way? Yes, I did. Sorry. Oh, sorry. Okay. This simple architecture that we have here, doing these top mitigation strategies, that's kind of easy in there because you can see, well, okay, software updates and upgrades, yeah, go ahead, boom. I can enforce signatures and I can enforce that execution policies are the way I want because it's all in a nice constrained little area. So all of these right here, you can see that we can say we're doing all these things, but it breaks down when we get to our larger networks, which is where we're moving now. So now we have all these things that we're worried about, but then we have our trends. So we started simple, but now this is a more complex one, or probably a better term would be a more complicated one, for those of you who like to parse between complex and complicated systems. But a complicated network, we have other things that we have to consider. We're looking at it, we have clusters, we have farms, we have distributed networks, we have all these other things that are going on, and it's no longer constrained. So orchestration becomes very important when we're talking about this aspect. Also, we have to consider things like when we're looking at these large architectures, how do I verify that what I'm doing is working? How do I verify that I'm firing on all cylinders at all time? How do I take care of things like the data lifecycle? When I have a large distributed architecture, I have multiple copies of the data. I have to make sure that I'm able to take care of the whole life cycle across all the different points. Sustainability. This is one that's oftentimes overlooked. These complicated architectures, along with machine learning, these are resource hogs. Okay, so when you're talking about the physical look at your architecture, you need to really be able to size up and without going over the cost of what your customer is prepared to spend. If you know you're going to go over that cost, you better start setting expectations pretty early on. Because as you see, we can go through all of this and we can see that we have our tenants, we kind of have all the things that we had in our simple network multiplied, but then we had the management of all of that and everything underneath that too, that we'll have to consider. So let's talk about the cloud. Even though the cloud is, over a decade old, we find that we still have, we consider the cloud a relatively new advancement because migration continues and cloud service providers are increasing their capabilities. So let's start, there was something that Gary McGraw mentioned in his work, he calls them touch points. So when we start with each of our views, starting as high as overview 1, let's identify our touch points. These are the places where you're going to have your breakdowns in security, okay? Because one, you have a handoff between one entity and another entity. So if you're maybe working with a corporation or an enterprise and they have everything up in a cloud and they think they've written very tight SLAs, that might be the case, but there's still that extra mile between the cloud and the on-premise stuff, okay, the on-premise network. What are we doing to assure that we have security in those areas, okay? And partners, any time there's a touch point with anything that is outside of your purview or outside of your control, this is something you need to take into account, because this is the first place where you're going to find a breakdown most likely. The architect's view, who uses the system? Now, we can talk about the physical versus the virtual or the logical views. We can do some creative things with logical views, and we'll talk a little bit more about that when we talk about zero trust networks, but the ability to isolate yourself and to do the segmentations, you have a lot of flexibility on how you want to do that. You can do that by where things are geographically, you can do things by the users, you can do it by the service, you can even do by time, however you decide to slice it up. The data view. This is probably the most important view right now, that, in my opinion, because we're finding that everything's becoming data-centric. We say that our architectures, we've got all these other things going on, but at the end of the day, it's data that we care about. It's the data that we receive, the data that we're processing, all of that. Not only do we want to make sure that it is good data, but we want to make sure that we can keep it good, basically. And we can do so using our basic first-order principles like integrity checks and things like that, which we always do. But we still need to be able to identify all of the places that we need to do this. Our network view, again, we have physical, virtual. Our systems view, our hardware, our software, our firmware, our VMs, containers, all of this, we have to figure out, we have to know how are we going to secure all these? How are we going to assure that they're going to not only work in our current architecture, but how do these things work when we go going forward as the architecture expands and grows? Because one of our requirements in general when we're doing security architecture is to be able to make it breathable. So the user view, how will the user use this system? And when we talk about the user view, I want to clarify here, there are two types of users that we're going to look at, so that's why I broke out the attacker view, which we typically don't like, you don't always see it in an architecture drawing, architecture report. But the users themselves, you have the clients, you have the operators, you have all these different people that they have one view of the system. And then you have this other view, the attacker view. And oftentimes there's a tendency in cybersecurity to jump first to the attacker view and not consider the other views, which of course makes the architecture more brittle when you do that, because when you do that, you're just like, oh, I gotta take care of this problem, this problem, this problem, as they keep coming up, thereby missing the opportunity to do something that's more, what's the word I'm looking for, more flexible. So what are our cloud strategies? Well, we have to uphold the shared responsibility model. Again, this is where those touch points become so important. We have to use secure cloud IDM practices. Now, identity management, access control and management, that's just the first step. Again, it's really important if we're doing things with the cloud, we want to make sure that that we put extra checks in on the data. We want to be able to have secure cloud knowledge practices, or knowledge management practices. So we want to make sure that what we're doing in one area, that the other spots know that we're doing it, and that we have a coherent way of maintaining that. Again, implement network segmentation, microsegmentation, encryption in cloud environments. This is really, this is kind of another layer, and it's really highly touted using this in zero trust environments and zero trust architecture, but it really does apply for pretty much any architecture as we scale up. We need to secure the data in the cloud, all aspects of the data during that data lifecycle. And we need to defend the various environments, which include, of course, the defense and as well as the integration environments. We need to secure automated deployment practices through infrastructure as code. So again, we can pick on the cloud vendors. They've been getting better and better. But when we talk about the infrastructure, that is so key, because if you are the client and you are using the cloud, you are relying on the vendor to get it right with their routing, their DNS, their infrastructure. If they don't have that right, not only are you vulnerable, you don't even see that you're vulnerable because it's underneath you. We need to account for complexities introduced by the hybrid and multi-cloud environments, which we kind of talked a little bit about. We need to mitigate risks from managed service. Again, we can do things to mitigate risks with our managed services by, one, having tight SLAs, but also we need to make sure that the people who are executing these SLAs have our same interest and our same goals in mind. And it's very hard to be a mind reader in these environments. And we need to manage cloud logs for effective threat hunting. This is where some things like where we're seeing the rise of AI and SOAR technologies and things like that, where you're actually seeing an improvement in this space, because if it's done right, it can help reduce your workload. That brings us to our second object of desire here. Artificial intelligence has really taken off, particularly with the implementation of the large language models. So we need to understand, first thing when we're dealing with artificial intelligence in any architecture, is we need to understand the learning data source. So if somebody says, we're learning your environment, okay, because that's a pretty common one that you'll hear with security vendors. We'll just sit passively on your environment, collect data, learn it, and then we'll be able to create the profile. That is okay as long as your environment is pristine. But because we don't do baselines, it's very hard to find a pristine environment. Okay, so what we typically end up doing is we try to understand as much as we can about the data source that was the learning data source. And this is why, actually, believe it or not, you will find some places will not use AI and won't even, they won't go to the cloud, they won't do a lot of things because they really can't be assured that they have that pristine source for the learning data. We need to understand how the data is distributed, not only in terms of the cloud, but when we're adding in artificial intelligence and machine learning, take like your large language learning models. Those are basically just what they do is every time they get more data, they just hoover it up and use that to learn more. So as we're doing this, we can create an environment where we can create some very deceptive data very quickly. Understand where and how hallucinations occur. I love hallucinations because all it really is, as a friend of mine told me when I first started delving into this, was it's all probability. So a hallucination is it's just taking the most probable wasn't working, the second most probable wasn't working, so it's all the way down to the bottom and says, let's try this. Okay, that's your hallucination. I have a friend who's a statistician, and she used to always say that the interesting thing is not what's under the bubble, it's what's on the ends. And that's where your hallucinations come from the tails. Plan for periodic random verification of results. So the reason we say this is, again, we are seeing a lot of AI being applied. I call it, they're kind of like throwing it on the wall to see what sticks. We're seeing this applied in a lot of different environments, but it's not necessarily being applied responsibly. So in order to get some sort of handle on it, a good thing to do periodically would be to check your AI outputs and verify them against something that is, like a hand-done output, or something that is a known good output. Because you really, it's not hard for AI to go off the rails, and especially with LLMs where they are constantly relearning. So because of the relearning, it's easy to slide off. It's also, for those of you who are aware of them, you have the adversarial perturbations, if everyone's familiar with those. Those are even more troubling because they're hard to detect, but they can throw off the accuracy of your model. Like, they're actually undetectable to humans and to the machines, but because they perturb the data ever so slightly and consistently, they can bring a model from 90% accuracy down to 50% accuracy. So this is why you want to periodically check against what you know is good. Understand where the input data touch points are from the users as well as the machines. And then there's this little thing called MLSecOps, because we couldn't have DevSecOps without having machine learning DevSecOps. And lo and behold, this is kind of like a best practices for your machine learning software, looking for the bugs that could be in there too. Zero trust is another big one. Zero trust was, the government declared, thou shalt zero trust on our sites. So zero trust is kind of a mixed bag, okay? Truth of the matter is, as we unmask zero trust here, it's really just best practices, okay? So when we consider that, we say, okay, well, let's start looking at all the views and recognize where we're going to have conflict between what we want with resilience and what zero trust dictates. Zero trust wants us to be nice and confined and challenge everything, but resilience says things like, I want redundancy, I want resourcefulness, I want to be able to reapply the resources to another service so that I can actually keep functioning. These are things that are kind of in direct conflict with zero trust. So we have to start by, one of the problems I have with zero trust in general is that it assumes that everybody's going to follow the cyber kill chain model. Not every attacker wants to do that. Sometimes attackers are happy to do a well-timed disruption, and it can be highly effective. Likewise, a well-timed denial service it can be highly effective. So we have to consider all of the views when we look at that, when we are examining zero trust. We also, zero trust does a pretty poor job of addressing supply chain security, and also does a pretty poor job of addressing hardware security. And it doesn't do a stellar job with software either, but at least it acknowledges software. The encryption challenge. So what's the encryption challenge in zero trust? Well, zero trust, I was actually, one time I was being critical of zero trust and somebody, and I was giving a presentation and somebody brought up, yeah, but we encrypt everything, so it's okay. And I said, so if I get on your network and I don't belong, I stole somebody's credentials, and I just decide to sit and lay and wait and, learn more about your network and do something that the person whose credentials I stole, I'm allowed to do, I'm allowed into that service, but I do something I'm not supposed to do in that service. I'm encrypted, so I guess I'm golden. You don't even know what I've done. And of course, I mentioned the resilience challenge, how zero trust, because it tries to constrain everything into nice, discrete little paths, and resilience says, hey, no, we got to find ways to work when things go south. We need to stay operating in a semi-secure mode. So zero trust is, the resilience challenge says, well, I want to be resilient more than I want to actually be fully trusted. So what are some of our solutions? Well, we're not going to get through this whole list. So zero trust. So we talked a little bit about zero trust. What we can do is we can take some of the good principles of zero trust and we can apply those, but not necessarily say we're going to put the full trust in zero trust. We can go ahead and add to our zero trust model by identifying where our supply chain vulnerabilities are and how do we actually identify hardware problems that can go south on us. So when I'm talking about my hardware problems here, I would like to see more of the vendors sharing information about the life cycle of their components that they're using in hardware. And it's not impossible to get that data, it's just that they're reluctant to share it. So the intrusion kill chains, again, I think we talked about this. CKC is just one way that we can do something, a system can be brought down, but it's not the only way, so we have to consider when we're building our architecture, how do I deal with disruptions and denials and things like that. We talked about resilience, we talked about DevSec, well, we didn't talk about DevSecOps, we talked about MLSecOps. DevSecOps is a decent enough approach for your software, but it's not going as far as, say, like what Gary McGraw has you do in his software security. Gary's looking for things like preventing unhandled exceptions and memory leaks and things like that that really get to the heart of our problems. DevSecOps doesn't necessarily look for a memory leak unless it knows to look for a certain behavior. Risk assessments, we do those. Intelligence operations and SOCs, these are all things that we already have here. These are just examples of things that we already do, okay? It's just a matter of getting these to actually, of doing these things together, and when we look at a larger architecture, how do we make that happen? Okay. So what are our trends? We talked cloud, we talked AI, we talked about zero trust. Biometric authentication, here's another little problem for us, right? We all know that biometric authentication is good and solid. The only problem is you're storing something that is about you personally, digitally, and you got to hope to God that it never gets found. Having a conversation with a friend of mine out in the hall, and we were talking about how AI in particular is getting access to a lot of how we authenticate ourselves. Boy, that could be pretty frightening if it's getting a hold of my biometric data. Although maybe mine will break it, I don't know. The blockchain, we still have the blockchain in our sites here. The problem with the blockchain is good if everybody trusts everybody who is signing off. There is one little problem of what happens when when a small group of people decide they want to collude on the blockchain. So now you're signing off on something, and I get two or three other people to sign off on the same thing, but except that it's flawed. Okay. The container security is all you need. Yes, that's one of the things I've seen pop up here, because container software is isolated and it can run securely on a system. Still don't trust it. So I would say go ahead and you can trust it to do some things, but again, it touches the system. There's a touch point where it has to interface with the system. There will be problems. Over-reliance on cyber insurance. Of course, everybody wants to have insurance and believe that pass the buck to the insurance companies. Well, they have limitations on what they'll insure too. So, quantum proofing everything. I think we need to get a little better handle on quantum before we start quantum proofing everything. There's like any other newer technology, there's a tendency to say, hey, we've got this new technology that's going to destroy the way we do everything. And then we find out that, no, it doesn't really. It does make some changes occur, kind of like with AI. AI certainly has not replaced any of us. And I don't see AI replacing security architects anytime in the near future. I could be wrong, but I think they're going to I think AI has limitations, and we're starting to see some of the limitations. If we can get the blinders off, we can see even more. And of course, our silver bullets for things like ransomware and things like that. Bottom line is, our problems are the same problems that we've always had. They're just bigger. And not bigger in terms of more difficult, bigger in terms of quantity. So what's really important is that not only do we do our first security principles, but they do require a little extra effort because of orchestration of our efforts. And not only orchestrating what we're getting the results for, but keeping those results secure. We have to understand locations of touch points. This is really important when you're talking about large distributed networks. One of the things that a lot of people tend to overlook is when you have multinational touch points in the cloud, you have infrastructure. Well, understanding where the peering agreements are is really important, because if you don't understand where those peering agreements take place, you could be passing your information through a hostile area, and if you don't have access to their routes, he who owns the routes owns the data. Okay, so it's really important that you make sure that you have your data that your data flows are going exactly where you want them to go, and that's why I say the data-centric view is so important. And of course, always understanding where your residual risks lie. So at this point, I'm going to open up for Q&A. Yes, we have time, and I think I timed that just right. And anybody who has questions, feel free to come up to the microphone and go for it.
So on the presentation, a lot of these are objectives that we need to accomplish. Most of us kind of have probably a lot of that list already in our heads. We know what we need to get, we just don't know how to get there. So if you had to pick one of your biggest priorities, what would be an example of a how to achieve that in the cloud?
Okay. In the cloud or just on any of them?
Cloud.
Okay. Okay, so I would actually say, when I look at a cloud implementation for anything, I always start off by looking at the different points of presence of the cloud, and dig down to where are the routes in the cloud. So to get to that, I start with a basic dig, right, for the cloud, for the CSP. And then I see who the IP addresses are. Then I go and look them up to the autonomous system numbers to see who's actually doing the peering on this, right? So who owns the autonomous system numbers, and then, of course, you want to dig into finding out where the routes are actually pairing together. So if I see an autonomous system number that comes out of, say, China, right, not uncommon, on the way to a trusted site, I might see China going to Japan. No, well, okay, China going to Philippines, okay. And I said, well, Philippines, I trust them, but I don't trust China, okay. Well, now I know I have a problem, so I have to put into my service level agreement and say, no, you're gonna have to reroute the traffic from this organization to over here, okay? Does that help?
A little bit, yeah. I'm just thinking in my head of what tools we have in place.
Oh, okay.
To provide that kind of detail.
So I have to say, I am horrible with tools. I usually just do it the old-fashioned way. So I actually do look these things up and then, put it as part of the report that you're going to put together. Say, you need to be aware of this because of this data that traverses here is vulnerable, and this other data here, particularly on the infrastructure piece. Because to me, the infrastructure of the cloud is the key in all of this. I have my DNS servers up there, and I have my routes up there. Those are the two big areas where I can change the flow of traffic very easily, and the user never sees it. So that's why I try to look at that without a tool. Any others?
How would you kind of assess the level of controls that are put in place by the cloud service providers, especially the large cloud service providers? Because the kind of residual risk that you can assess in your own premise, a data center, now what would give you that kind of assurance on the residual risk?
So supposedly the service level agreement is supposed to take care of that, right? I would say, though, I would continue to do some digging along the lines there. It's not hard to find, like, where, you can look up the major cloud service providers. Supposedly, and also, they have, like, their public cloud, and then they'll do their private clouds. Their private clouds tend to be a little bit more, have a little more security written into them, because their customers usually tend to be the U.S. government, and they can insist on these things. But again, I start with the basic tools. What can I reach? What can I not reach? When I see something, map it out and see, where are the vulnerabilities that you can see, okay? A lot of times they're going to hand things off to you when you get to your virtual environment and say, you're responsible. And a lot of people say that, okay, I'll take responsibility for my environment. So everything that's in my domain, abc.com, I've got all those virtual machines locked down. But then I have to come back and make sure the provider is doing what I want to do. And short of a service level agreement, and the reason we do those is because the legal liability that they will incur, and that's basically that's the fear of putting the fear of the lawyers into them that they're going to do it right. But you actually need, I don't know enough about a lot of the CSPs to let you know if they'll come in and let you audit them too. I know that they've let the government do it, and the government, I won't say which one that the government's pretty happy with. So.
Why I ask this question specifically is that even if you have a service level agreement and you're assured about the legal liabilities, but in the banking sector, it is more about protecting customers' interests.
Yes.
And I don't think that damage can ever be covered through legal liability. So from that perspective, there's always a debate between the CISO's office and the technology function and business function that
Yes.
whether to go on cloud, because the agility and the scalability is all there in cloud. But when it comes to security, protecting customer information and transactions, there's a huge challenge that the CISO sees in giving the sign-off.
Yes, it's funny you mentioned the banking sector because I've seen so many different risk profiles in that sector too. Some places are like, no, we're not doing anything with the cloud. We're not, you're lucky you can just get to our website. We run everything ourselves because we don't trust anyone. And then you have others that are a little bit more open about it. What it comes down to is the risk tolerance on each of these places, and our job is as architects is to try to help them to is to enable their vision. Even, it's important that we point out where the gaps may still exist, because they may still say, hey, I'm going to go with it anyways, and you don't want to be the one that says that here's the, well, I designed this architecture and it was broken into. Well, it was broken into because you didn't do what I told you to do, right? So it's really important to annotate where those where that residual risk lies, and if possible, to even show how it could be a bigger, the likelihood of it happening might be greater than they might think. So,
Thank you.
yes.
Hi, Dr. Char. So it's very interesting that we went from a CIA kind of paradigm to your Rubik's Cube, and now we're in this world with exploding fragments, so many different pieces to meet your 4 Rs,
Yes.
right? So how do you kind of think about simplifying this whole stuff? Because really from a normal person, it's very difficult to look at all these pieces and say, how do I really know for sure that it is secure? And to what degree is it secure? How do you even define it?
Okay, so typically what I like to do whenever I'm doing any architecture work or I'm recommending anything in architecture, I like to start off first by understanding who the customer is and what their business is, what they're trying to accomplish. Because I find that it's easier to actually put something forth that supports what they're doing securely than to try to integrate all these other things, because it becomes a nightmare. And the reason I say to do it that way is because you can eliminate a lot of other, second time I did it, a lot of unnecessary services and things that are going on. And this is actually an old principle when I first started doing firewalls, actually, that Marcus taught me. He was like, get rid of everything first, then turn on what you want one by one. And if you do that with your security architecture, it's a lot easier to start supporting all of these other crazy things, because you say, okay, I need to be able to have maybe this service available 24/7, right? And in order to have it available 24/7, I need these machines, I need this software, I need this, and you go through the whole list of what you need, and they say, and I need to also maybe have redundancy on this aspect of it. So now it becomes, I'm building it out, as opposed to I have something and I'm trying to move it around. Does that help?
Yes and no. I mean, I'm just saying, I mean, I mean, even if you think from the perspective of firewall, earlier it was very clear, simple wire coming in and here you check, but now
Yeah.
your piece is living in cloud with so many different pieces. And I was thinking that the word zero trust kind of is more like I'm fully trusting the architecture. It's not zero, but it's maximum trust.
Yes.
Right.
Zero trust is really is just best practices. I mean, I sat in the room when those guys were putting that together, and I was like, where's the magic? This is just best practices. So, and they have done nothing to show me that they have done anything different with it. But yet it becomes, like you said, a very loaded term where people think that everything, I've got this perfect solution, and it's not. So yeah, and that's why you come back to the simple part.
Yeah, so a lot of my clients seem to have no idea what they want. So
That's a common one.
we do a lot of strategy, investing, and meet with the owners and meet with their very, very small team, if they even have a team. And then we come up with a type of security for them. And then when we implement it, they say it's too secure, it's too much. So how do we work around all the man hours and the finance? Because we want to keep the CapEx low, we want to keep the EBITDA happy, all right, and their P&L if they have a bunch of franchises, but still get all the information that they actually think they need or want, or because they're confusing me. So I don't actually.
So this is a very common problem with the clients not knowing what they want, and thinking they typically I'll hear something like, I just want to be secure. And then when you ask them what aspect of security is most important to them, they'll say whatever the flavor is at that particular time, and when you point out the other one, they'll change it to that. Like if I actually sat in a meeting one time, somebody said, confidentiality is the most important thing to us, and I said, well, so then availability is not? No, availability is the most important thing to us. So I feel your pain on this, okay? Again, I'm going to come back to start off understanding what it is that they want first to support the business, because if people think that security is becoming a roadblock, they will go around it. no doubt. Because they will go around security, we not only try to make it, we try to keep like things together. So sometimes this is a case where maybe like segmentation can be a big help, because there may be areas that you can say, I can put this group of users together in this area, and they never really have to go anywhere because everything they need is right in here. Okay, and you can do this virtually, so it makes it adds a bit of complexity to what you're doing with your network, but it also might make it easier to accommodate what this varied group of users wants without having to, do extra authentications that they so abhor. We can, there are good IDM solutions. You can do single sign-on and things like that, but again, depending on the risk profile and the threat landscape for your client, those may or may not be viable solutions. High target clients probably are less, I would be less inclined to recommend something that is all-in-one on those ones, so.
Okay, thank you.
This is my first time coming to these conferences, and all the products I see talk about zero trust down at Expo. And this is the first session I hear that it may be in direct conflict with resiliency and all of the pitfalls. That's good to hear. So what are the good things about zero trust in software that you like?
Okay,
Yeah.
so one of the great things about zero trust, I'll go so far as to say, is we have a saying a lot of times, people who've been in cybersecurity a long time will say, people don't want to hear eat your vegetables. Well, that's kind of what zero trust is. It's eat your vegetables, but somebody came up with a clever way to market it, so now we have all these best practices in place for zero trust, right? So it's, like I said, it's not a bad thing. I just think it's being over-marketed. So it's actually kind of a good thing that we're getting people to finally do what they're supposed to be doing, or finally to eat their vegetables.
So what are the specific features? Because you said it does a relatively good job in software landscape as compared to hardware and the other aspects. What are the good jobs that it does in software landscape, to be honest?
Okay, so one of the things that I really like about zero trust, software-wise, is the ability to segment your network, micro-segment your networks, because you can segment by service, by user groups. You can, however you see fit, and you can make these temporary assignments, right? You can create the VLAN, do your thing, and then have it go away when it's no longer needed. So that's, and you can put all the zero trust things around it that you want, and because one of the things that makes a system reliable is not only that it does what it's supposed to do, but it does it in the environment that you've specified and for the time period that you specified. And people usually lose track of environment and time. But if you're in zero trust with your VLAN and you have it set for a certain time and then it expires, it goes away, boom. You can do that in a regular world too, but people would be more inclined to do it in zero trust with the microsegs.
Thank you.
Oh, no pressure. These principles are really good, and I think most of us know a lot of them already. But when the dirt hits the road, is also when we start talking about risk-based and all of this nice stuff, and we need to do differentiation between these principles and priorities of money and all of the other stuff that we discussed. So how do we better address that? There's no, it would have been so nice if we came up with a model with tiering and, all of that stuff. What's your take on this kind of problem space?
Yeah, so this is kind of a wide open question, and actually the best thing I have found the best thing that still works is when you are done putting everything together, that you give your customer the full rundown, and they're like, oh yeah, this is great, and they say, and here is the risk that remains. And you really spell it out for them. Say, I actually one time did one for a bank one time overseas, and went through everything with them, and I said, here is the risk, I said, you're good on all this right here, but here's the risk that remains. I said, you have this homegrown app, and you haven't let me see, we know nothing about the source code, and yet you got a lot of users using it. In fact, all your users can use it. So aren't you worried that this app could go bad on you and somebody could steal money from you? And they said, well, what's the likelihood that that's going to occur? I said, well, you've got enough users. I said, I can't give you a percentage because I don't know the percentage, but I said, if I wanted to beat on it long enough, I would try to find a way to break that and get through and steal some money. And they said, well, how much money would you steal? Now, of course, I made the mistake of thinking small, and I said, well, maybe $1,000 a day, and I'd be happy. And they said, well, that's just the cost of doing business. So understanding what their pain point is also when you tell them the risk is important. So you say, hey, you have this residual risk left here, and there's, you know, you seem to be willing to live with it, and it's tied to these assets over here that cost that. That's, unfortunately, that's, okay, I think that's it. Any other questions I'll take in the hall.